Okay, so as in the last video we have discussed about the relation between the electric potential and the electric intensity, in which we have considered two charges. One was the unit positive charge, or you can say test charge. Another was source charge, or you can say point charge. We placed a test charge, which is denoted by Q naught, is placed at A point, right? We have considered this point A naught to the B point, which means it is going to B point against the electric field, because we know that source charge is generating the electric field and the direction of the electric field is like this, but this charge is moving in this direction, so of course it is moving against the electric field. Then the work is stored in this body, or work is stored in this charge, which is in the form of electrostatic potential energy. Alright, in the last video we have discussed about this, and of course we have discussed about the formula of it. Del V is equal to, it is the dot product of electric field intensity and the displacement, or small displacement, or you can say E dot del R. We have, by the way, dot product between this, right? Now if I'm going to remove this dot, of course if someone asks you, basically the topic which we are going to discuss today is very important, very much important in terms of MCQs. You can have a lot of MCQs from this what topic. So let me write this. Today is the most important topic in terms of MCQs, right? So multiple choice questions, multiple choice questions. All right, now if I want the magnitude of it, magnitude of what? Magnitude of potential difference. We know that potential difference is equal to what? Del V is equal to E, right, dot del R. Now I want magnitude of it, right? I want magnitude of it. So of course when I'll be removing this dot, I'll gonna have a function called cos theta, right? So let me put this here. So del V is equal to E del R and cos theta. So theta is basically an angle which is showing an angle between the electric field and the small displacement. So let me write this here. Angle shows the, or it shows the angle between electric field and of course the displacement, which is represented by del R. Alright, now this is what we call the magnitude. Magnitude of what? That too, magnitude of potential difference. Magnitude of potential difference. Of potential difference. Magnitude of potential difference. Right? Now for suppose this charge is moving, we know that against, right? Work is against. So of course the theta which we will be using here will be what? It will be of course 180 degree, since it is moving against. So work is here against the gravitational field, right? Against the influence of it. So it is against. So of course we know that cos 180 is equal to -1. We have discussed that in very detail when I was guys telling you about the angles between the electric field and the del R. I have taught you there what will have the values. No, basically when we were discussing about the electric flux, there I have taught you about the angles, right? So you can guys go and check that video in which I have taught you in very detail about the angles, right? Angles of cos, where the cos will be positive, where cos will be negative, where it will be minimum, maximum or zero, right? So now cos 180 is equal to -1, right? So let's put this. Del V is equal to E del R cos 180, which is of course equal to minus 1, right? So finally what we get is minus E del R, right? Now we know that electric field cannot be negative, alright? So let it make it positive. So del V is equal to E del R. I want this electric field. So electric field is equal to del V upon del R. This is basically potential gradient. I am going to tell you what it is. Potential gradient. Remember when I was telling you guys about the electric field, force per unit charge? I have taught you another unit for that as well, and that was of course volt per meter. Here you can see, and I have taught you there, volt per meter is also a unit of potential gradient. So here we have got that the unit of potential difference is what? It is volt, and the unit of displacement is of course meter. So here we got that electric field is also equal to volt per meter, and volt per meter is also a unit of potential gradient. That day I have just taught you that the volt per meter is also a unit of potential gradient, but today we have derived this as well, right? So this is basically potential gradient. Now let me tell you the definition of it, what this potential gradient is actually. Definition, right? So the moving rate of charge of potential difference with respect to distance or per unit distance is what we call the potential gradient, right? Potential gradient, right? Let me highlight this formula, not formula, however definition. So the moving rate of charge of potential difference per unit distance is what we call the potential gradient. See, the moving rate of charge of potential difference per unit distance is what we call the potential gradient. Alright, so here we have completed our potential difference. In next video we're going to discuss about the last topic of this chapter, electric fields, and of course that would be electric dipole. We're going to discuss that in very detail. Initially we'll be going with the concept of the electric dipole, what it is. We're going to understand that by the help of diagram. Then of course we'll be driving the formula for it, and I'm going to tell you other units or unit of electric dipole in other system of units as well. So this was all for today.